Okay, we are going to start the probability distribution of discrete random variables. Let me tell you about this discrete random variables first. You must know that what do we mean by this. You guys have heard about the discrete data and the continuous data, okay? The discrete data and the continuous data. Can someone tell us quickly what is the difference between the discrete data and the continuous data? Hmm? Or should I ask? Yeah, let me ask from Iman Hassan Khan. Iman, can you tell us the difference between the discrete data and the continuous data? We have covered this, by the way.
सर डिस्क्रीट डेट वो होता है जिसमें certain values होती हैं और continuous can take any value.
वेरी गुड, क्या बात है, कमाल कर दिया। फिजा आप बताएं।
सर डिस्क्रीट जो है वो डिस्क्रीट होता है।
और कॉन्टिन्यूस है वो कॉन्टिन्यूस होता है ना। इतनी सी सिंपल सी बात है, लोगों को समझ नहीं आती। चलें खदीजा से पूछते हैं। यस खदीजा।
सर डिस्क्रीट मतलब कोई डिस्टिंक्ट वैल्यू हो सकती है
अच्छा,
और कंटिन्यूस कोई भी मतलब उससे वैल्यू हो सकती है।
शाबाश है। Now the people who will be looking at this video, what would they think about me as a teacher? I'm telling that we have covered this, guys. Discrete means the data that you collect by counting. For example, the number of chairs, the number of pencils, the number of cars. Like if you look at this probability thing, so that can be like you're tossing a coin. So what is the number of heads? You're rolling a dice. So how many times you get a 6. So that is your discrete data, the values that exist as a whole number, okay? Discrete means that you can count, okay? You people can count, okay? Now the continuous data is that you people measure. Like I just finished my further maths class. So, there is a chapter about the continuous random variables. Okay. The continuous random variable is that you can have a question, okay, what is the probability that you finish a question in less than 5 minutes? Okay. Because, time is a measurable quantity. You cannot count it. Okay, what is the probability that you make a jump of let's say between 2 and 5 meters? So length is something which we can measure. So the lengths, the times, the durations, the volumes, all these things, they come under this continuous data. Okay, so in your A level maths, you must know how to draw the probability distribution of discrete random variables. Okay, so discrete would mean, again, I repeat that the number of heads, the number of tails, the number of green balls, the number of students doing this. So that is the discrete data. Okay. Now, the second, if it's clear that what is the discrete, what is the difference between discrete and continuous, then can I move on to the probability distribution? Is it clear now that what is the difference between the discrete and
Yes,
the
yes,
yes?
sir.
Okay,
sir.
now. Okay. Abhi, I'll be asking you 5 minutes question, maybe in next 30 minutes. So please be alert, okay? Now, so this was where you measure, okay? Acha. Now, the probability distribution. You guys have heard about the frequency distribution. Have you heard about the frequency distribution? Yes, you have heard this a lot. Like, you have, there is X, there is F. Remember that murgi ke ande wali example, like my hands are laying 5 eggs for that I get 5 eggs for 6 days and 6 eggs for the 10 days and 7 eggs, let's say for 8 days and 8 eggs for this for the 6 days. Okay. So this is the frequency distribution. When you have the frequency distribution, guys, you find the mean. And the formula for the mean is sigma fx over sigma f. And then you find the standard deviation and the variance over here, okay? I'll be just writing the formula for the variance because I'll be talking about the variance in this probability distribution, okay? The variance formula was sigma x square times f, or fx square over sigma f and minus mean square. That is the formula we use mostly. There was another formula that was sigma x minus the mean whole square over sigma f. Okay, so this is what you people already know about the this is the frequency distribution. Okay. Now I will be relating that probability distribution with this. Now, what is a probability distribution? You focus on a certain event. For example, um, you people are rolling a die, okay, and you want to make the probability distribution for the outcomes that you get, okay. So what do you get uh, when you roll a die? You might get a 1, 2, 3, 4, 5, or 6, okay. So that is your x, and here it is probability that x equal to x. Like, what is the probability of getting a 1? That is 1 over 6. This 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 is 1 over 6. Now this table is showing a probability distribution, and this x over here is a discrete random variable, okay. 1, 2, 3, 4, 5, and 6, that is a discrete random variable. Okay. So for example, you people are tossing a coin twice, okay. You people are tossing a coin twice, and you are studying the number of heads, and you want to write down the probability distribution, make a probability distribution for the number of heads when you have tossed um, a coin twice, two tosses of a coin. Okay. Now you must be very good at the probability, the basic probability, the topic that we have just covered. Okay. When you toss a coin twice, what can be the possible number of heads? Anuj, can you tell us? You are tossing a coin twice. So what is the possible number of heads?
सर हाफ प्रोबेबिलिटी होगी दोनों बार, तो मैक्सिमम 2 दफा हेड्स आ सकता है.
Okay, दो दफा. Okay. Hafsa, Atik, what are the possible number of heads when you toss a coin twice?
Sir, 2.
Bas, 2.
सर 0 भी हो सकता है, 1 भी हो सकता है, 2 भी हो सकता है.
ये चीज I wanted to hear this. That's a great shot, Anuj bete. Mashallah, mashallah. Anuj is a genius girl, mashallah. Bhai Anuj, beta, you must offer a sadka kind of a thing, because mashallah itne zahin log bahut kam hote hain beta, mashallah. Okay, maybe you can make a dekcha of biryani someday and you send it to the school. We are normally these days sitting very hungry at the school, okay, especially in the chemistry lab. So Anuj, will you do that?
ठीक है सर.
Okay. We shall wait for that. Okay. Now this is head. Guys, if you draw that table diagram, that can help. Okay. Look at this. That was what going on in Anuj's mind, not in Hafsa's mind. Hafsa, what should I say for you? That you
सर मुझे लगा आपने कहा maximum probability क्या होगी.
so that means you have got a hearing problem then, है ना?
जी सर, यही समझे.
Okay, no problem. That's just joking. Okay, now you see that you get head, tail, head, and then there is tail. Okay, so since we are interested in the number of heads, so look what will be your probability distribution like. This is 0, 1, 2. So this is going to be 1 over 4. When there is no head, this is the situation. When both are tails, that means there is no head. This is 1 over 4. When there is one head, so these are the two cases where there is one head, that is going to be 2 over 4. and then this is 1 over 4. Okay, so this is the probability distribution. Okay, let me give you one more example. Suppose the question is that you are rolling um, a die twice. Okay, and then this can be 3 times, 4 times, even n times. But since I am starting, so I'm going to start with the easier examples over here. Okay, so you're rolling a die twice, and you have to make the probability distribution for the positive difference of the numbers shown on the dice. Okay, so what will be these differences, bacho? Yes. Yeah, okay. Let me ask. Let me ask. I'll not let you people sleep or run away. Okay. This is X, probability X equal to X. Okay, guys, be alert. Isha Kamran, if you roll a die twice, so what can be the possible differences? Isha, Isha, you are very vocal in your further maths class. Where are you now? Oh, she's absent. She's always like, away whenever it's a math class. So, okay, let me talk to her. Okay. Amna Jamal, what are the differences when you roll a die twice on the numbers shown by these two dice?
0 to 5.
Very good, mashallah. 0 to 5. Absolutely right, beta. Because you see, if you draw quickly a table diagram like this, okay, you have 1, 2, 3, 4, 5, 6. Okay, then you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then you have 6 here. Okay, so you have this 1, 2, 3, 4, 5, and 6, and you are interested in the differences. Okay, so you have 1, 1, the difference is 0, 2, 2, the difference is 0, 0, 0, 0, 0. Okay, when you have 1, 2, 2, 1, so this is going to be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 2, 1, 3, 2, 4, 3, 5, 4, 6, 5. Okay, this is going to be 2, 2, 2, 2. People, are you like understanding what is happening here? Any one of you pareshan here? Oh, sorry. Why did I write? Oh, this was to be 3. Oh, guys, I'm making mistakes. No one is noticing it. Okay, this was to be 3 here. Says 3, 3, 3, 4, 4, 4, 5, and 5. Okay, so that is how you have this these differences over here. Okay, so is it clear why are the differences between 0 and 5? Why did Amna tell so confidently, yes, the differences are going to be 0 to 5? Is that clear?
Yes, sir.
Okay.
Yes, sir.
Uh, is Isha back or she's still away? Isha Kamran. Now this video is going to be an evidence that Isha was not here. हाँ देखा, where were you 5 minutes ago?
सर मैं नाश्ता लेने गई थी, sorry.
This is not on, beta. This is really not on. Okay. Acha, khair. So the probability, these differences are going to be, this is going to be like 0, 1, 2, 3, 4, and 5. Okay. Now the probabilities, 0 is 6 times here. Okay. This is 6.
सर पॉजिटिव नहीं मांगा हुआ, खाली तो 0 क्यों डाल रहा?
Very good. Positive and 0. Okay. Let's say very good question here. Who was that? Who is that
अच्छा
mathematician in our class? Who was
सर
this?
ऐसे मजाक नहीं करते
No, no, beta, no. This was purely a mathematical question. I'm really feeling proud that my students are so mathematical, mashallah. Bilkul, beta, you must go into such details, mere bachcho. Acha, now this is going to be how many times 1 is there? That is 10 out of 36. This is 10 out of 36. We have 8 times 2's, okay? 8 over 36. 3 times, how many 3's? There are 6 times the 3's. How many 4's? There are 4. And how many 5's? There are 2. Okay? Achha, I have drawn 3 different probability distributions. One is for the rolling a die, second was for the number of heads, and first was just for the the outcomes of one roll of a die. Now, please look at this column over here. I'm going to ask you a question about this column. What do you notice here or here or
Sir, the total is 1.
oh, very good, very quick. Okay. So whenever you have a probability distribution, the sum of these probabilities has to be 1. It is always 1 because when you perform an experiment, if you're showing all the outcomes over here, this is quite clear that the sum should be 1. Have you noted it down or not? You must note it down that the sum of the probabilities in a probability distribution is always 1. Okay, now are you clear that how to write the probability distribution?
Yes, sir.
Okay, suppose like I give you a question, like let's say there are 5 red balls and there are, let's say, um, 3 green balls in the box A. The box B has, let's say, there are 2 red balls, there are um, 3 green balls, and there are 5 yellow balls. Okay, you pick a ball from the box A and then you pick a ball from the box B. Now the question says write down a probability distribution for the number of red balls. Okay, you have to write down. You will be doing it in the meanwhile. I'm writing this question over. All of you, you write down or draw the probability distribution for the number of red balls. Okay? You pick a ball from the box A and then you pick a ball from the box B. Then you have to write down the number of, you have to make that probability distribution for the number of red balls. Please do that quickly. Okay, if you want to be drawing the tree diagram for this, being a bit clever over here, being a bit smarter over here, you should divide your data into the red and not red. Don't write all these colors, okay? Let's say you have here, suppose there are some yellow balls over here as well. Let's say there are 2 yellow balls, okay? Let's keep it like this. So this will be really difficult to make such a big tree diagram. So we divide the whole of this information into the red and not red, okay? So we have here clearly, this is 5 over 10, and this is also 5 over 10, okay? And then from here, again, you have the, you have red and not red. You have red and not red, okay? So this is 2 over 10, and this is 8 over 10. This is 2 over 10 and this is 8 over 10. Okay, so you see that the number of red balls, what are the possible number of red balls over here? बच्चों क्यों भाई? Hadia, what are Hadia, what are the possible number of red balls in this experiment? Hadia, बेटा जल्दी बताओ यार.
So 5/10 into 2/10 तो वो
नहीं, नंबर ऑफ रेड
6/10
बॉल्स कितनी, रेड बॉल्स कितनी हो सकती हैं, क्या क्या हो सकती हैं? जैसे इफ यू लुक एट दिस एग्जांपल हियर बेटे, नंबर ऑफ हेड्स कुड बी 0, इट कुड बी 1, इट कुड बी 2. So what are the possible number of heads here? Sorry, the possible
sir
number of red balls. Hmm?
sir is 7
यार क्या है यार भाई, क्या करेगा यार? Aisha, Harun, you tell us what is the possible number of red balls? Aisha is absent. Okay, Aisha is not here. Where is Aisha? Okay, Khola, what is the number of red balls bete? I mean possible number of red balls here. Hello, hello, Khola.
So 10 into
Huh?
5 over
What?
2/10 into 10.
Yeah, you people are giving me the probabilities. I'm asking you that what can be the possible number of red balls after you pick a ball from the box A and then you pick a ball from the box B. Hmm?
Sir, 0 to 2.
0 to 2. Who is that?
Amina.
Amna, did I ask you? There were people struggling with
Okay,
that and
sorry, sir.
you just spoke it out. Yeah. Okay. Aniyat, is it clear? Amna saying 0 to 2.
Yes, sir.
Why she's saying 0? How can this be 0? Hmm?
Sir, because there is a possibility कि box में से मतलब
Not red or not red, Ajay. Very good, beta. So this is going to
जी
be, yes, beta, you are absolutely right here. बच्चों जिनको समझ नहीं ना आ रही उन्हें चाहिए वो पूछ लिया करें यार. हम लोग कौन सा यहाँ पे फिर बाद में you people are going to blame me कि यार सर आप बड़ा तेज पढ़ा रहे थे, like you know, तो फिर ऐसे यार मजा नहीं आएगा. This is going to be 10 over 100. R dash is going to be 40 over 100. R dash R is going to be 10 over 100. Okay. And R dash is going to be 40 over 100. So we can see that, yes, we can have no red ball, like that is this case. Okay. So that is 40 over 100. We can have one red ball. That is, these are two cases. Here we are having one red ball here. So that is going to be 50 over 100. Okay. We can have both the red balls, that is 2. So this is going to be 10 over 100. Okay. So you have to see that what do we have to consider in the given experiment. Like here we were studying the number of red balls. In this example, we were studying the differences between the numbers shown by the two throws of these dice. Here we were studying the number of heads. Okay. And here we were just studying what is the possible outcome when you roll a die once. Okay. Is it clear? How do we write the probability distribution?
Yes, sir.
Yes, every outcome with its corresponding probability. Okay, once you have done that, as you have seen here, I have mentioned that we find the mean from here, okay, and we find the variance or the standard deviation from here. We also have to find the mean and the variance from these probability distributions. First of all, you write down the formula, okay? Now, the mean has a special symbol here that is written as mu. Remember this mu? We have used this in mechanics as well. What was this used for in mechanics?
Coefficient of friction.
Exactly. It was used as a coefficient of friction. This symbol represented the coefficient of friction. Here, this is going to be representing the expected value, the mean expectation. Okay. Guys, there is a clear difference between these two tables over here. Frequency distribution shows that what has actually happened. Okay. Frequency distribution shows the outcomes of an experiment. कि यार असल में ये हुआ. 5 अंडे 6 times, 6 अंडे 10 times, ठीक है ना? And this probability distribution is a theoretical word, is an imagination ki, okay, if you throw a die, one can come, like there's a chance of 1 out of 6. If you toss a coin twice, you might get a 0 with this. I mean, 0 heads probability is this, 1 head is probability. So this is a theoretical thing, which is in papers that this might happen. This is expected to happen, okay? So that is why this mean is called E of X, the expected mean, the mean expectation. There are many different words for this. This is called the mean expectation, okay? Or we can simply say the expected value, the expected score, okay? So this is E of X. Its actual formula is sigma X into the probability X equal to X over sigma probability X equal to X. If you look at this, this is absolutely same as writing this sigma. I'm just going to write it here, sigma X into F over sigma F. Okay. Now, instead of using the whole formula, we just use the sigma X into the probability X equal to X. Why am I not writing the denominator here?
Because it will be equal to 1.
Exactly. Because some sigma probability X equal to X means sum of all the probabilities. So since it is 1, so there is no need to write it down. Okay. So if you want to find this mu over here, this is mostly used as mu or E of X. So this would be 1 into 1 over X plus 2 into 1 over X plus 3 into 1 over X plus 4 into 1 over X, 6, sorry, मैं X बोली जा रहा हूँ, plus 5 into 1 over 6 plus 6 into 1 over 6, okay? So you have 3, 6, 10, 15. So this is 21 over 6. That is going to be 3.5. So the expected score can be 3.5 if you throw a die once, okay? Can you find E of X here? What is the expected number of heads here? Can you do that quickly? That would be 0 into 1 over 4 plus 1 into 2 over 4 plus 2 into 2 over 4. है ना बच्चों? So this will be
Sir, 2 1 over 4.
yeah. Oh, sorry. Yeah, 2 into 1. Thank you, beta. This is going to be 4 over 4. That is 1. The expected, you can say the expected number of heads is 1. Okay. He can ask you that, okay, draw probability distribution for the number of heads when you have tossed a coin twice, and then find the expected number of heads. So that is how you will be doing it. The expected number of heads. Okay. Similarly, you can try this as well. Can you please find the expected difference? Please find the expected difference from here. So you
Yes.
have calculated
जी
that,
सर यही आंसर.
yeah, okay, you have calculated this is going to be 35 over 18, है ना? That is approximately 2. Okay? So that is how you find the E of X. I believe you guys have learned how to do that. Okay. Now I take you back here. Okay. Now where you find this mu, the expected score, okay, there you also need to learn how to find the variance from a given probability distribution. Okay. Let me erase some of this area here. Let me erase this. You have seen the connection between all of this. Okay. I can remove this probability distribution. Okay. Okay, बच्चों. अच्छा. Now the formula for the variance is going to be, this variance is written as like this. This is how you will be asked to find the variance in a question on probability. Okay. You might not be using this symbol here for this discrete random variables. Anyhow, this can be used at times as well. Okay, so mostly we use variance of x. So this is going to be sigma x square times the probability x equal to x minus mu square. You can relate this to this formula. They are absolutely the same. Okay, they are absolutely the same. Now, suppose you want to find the variance of this given distribution here. So you see how you will be finding that. Oh, sorry. This is going to be the variance. क्या हो गया यार इसको? Come on, yaar. Why are you disturbing? Okay. Oh, I just took the what the hell? Okay. This is, the evil things here wasting our time. Where is the Saturn sitting between us? Where is the Saturn here? Go away, the evil powers from here. Don't disturb us. Okay, bacho. So this variance. Oh, come on, yaar. Come on, man. Come on. Okay. So the variance of this x is going to be 1 square into 1 over 6 plus 2 square into 1 over 6 plus 3 square into 1 over 6 plus 4 square into 1 over 6 and 6 square into 1 over 6. Do you remember what was the e of x for this? What was the mu? What was the mean? Yeah?
3.5.
3.5. Okay, so this is going to be 3.5 square. That is how you will get the variance from this. Let's find the variance over here. Okay, the variance of x would be 0 square times 1 by 4 plus 1 square times 2 by 4 plus 2 square times 1 by 4 and minus this 1 square. We have the mu over here. Okay, so let's find, this is going to be 2 and this is 4. 5 over 4 minus 1, so that is going to be 1 over 4. Is that right, bacho? Or I made a mistake here? 2 plus 4. Oh, this is 6 over 4. This is 6 over 4. This is 2 over 4 and this is going to be 1 over 2. Okay, you can find the variance from this as well. You can find this variance. Okay, this is the variance for this x, and you can find, you should find e of x, the expected number of red balls, and the variance of x. Please do that. Okay, so you have got the expected number of red balls, it is 0.7, and the variance of x is going to be 0.41. So I'm going to end this session from here, okay? So see you in the next class where we are going to study about the permutations and combinations. Thank you very much.